Recording now?
Recording in progress.
Okay, now we know recording is in progress.
Recording on.
Okay, so we said the relational algebra is a theoretical knowledge before we start creating our databases using SQL language. We have number of operators are there. We have unary operators, which are the basic operators. We have extended operators as well. We have covered last time project and select. The project, let's move to the next slide first. Okay, so the first one, which is project, we said that it's a Greek letter and we represent it as a sigma. Oh, sorry, pi. So whenever we have a project, we always look at the subset of the column, which means we always look at vertically of each of the columns. It's similar to what in SQL? Who can remind me? In SQL, it is similar to what exactly? It is equivalent to what clause? It is equal to select, which means we want to select an attributes. When we say the vertically, which means we are talking about the columns, we are talking about the attributes, and we are talking about the fields. Okay, these are the different terminologies we use. Okay, so this one is project. Now, whenever we want to use a project, which means we have to look at the attributes we are interested into. I have given you 3 examples. So I will look at the first one and the second one again. So the first one, it says list the price of all the products. So it says list. Okay. Okay, so is there anyone who is speaking? I can wait for you. Please do interrupt me in case if you want to, because I will never know if you are able to hear me. If you have any questions, please do raise your hand and stop me there. Okay, if I'm fast. Okay, can I continue? Please thumbs up so I can see that I should continue. For online people. Oh, here also, you can thumbs up. Okay, so now let's look at the first one. List the price of all the product. So as you can see, list the price, which means we are interested to look at the attribute called as a list. Okay, which is list, sorry, the attribute called as a price. So if you look at the table itself, we can see here the price is an attribute there in the table called as a product. The name of the table is not given. We have discussed last time. Based on the attributes, we can observe or we can identify the name of the table is a product. How we know it? We look at the P code, P description. When you read the P description, you can see here it says flashlight, lamp, box fan, which means these all are the products. So that's how we know that the name of the table or entity is product. So list the price of all the products. Do we need to include any other attributes? Do we need to include any other attributes? No, because it says only price. So how we can do it in project? First step here is that we need to use the Greek letter. We have it as a pi. Then we have to use a subset. The subset means we have to write all the attributes a little bit down to the character itself. So we call it as a subset. So attribute name. So what is the attribute name is price. The first letter will be always capital for the price. Okay, or any attribute we are using. If we have 2 letters, we have to use each of them capital. So for example, if we have 2 words, so we have, for example, P description. How we can write it? We will use a P as a capital, hyphen, and D as a capital. And the rest of them will be small letters. Okay. Now we have, let's go back to the question, list the price of all the products. We have selected our price, but we haven't mentioned which table we should take that attribute from. So how we can do it? In SQL, we use from, but in relational algebra, we use a parenthesis, the brackets. Okay. So we use a brackets here. It shouldn't be a subset. It should be equal to in the same line like a symbol. Only the subset will be attribute or we are using any other operators. Okay. What will be the subset will be only the attributes or any of the operator we are using. So what are the operators? I will go through each of the operators and you will understand what I'm referring to. In the parentheses, we will use here the name of the entity, which is product. Okay. So in case if you want to know how to write here, I have given you example in the next slide. This should be your final answer. There is something which I want to highlight before I move to the second one. Do you have any question? Any one of you, is it clear? Okay, I will wait for 30 seconds and then I will move to the second question quickly and then I will move to the select. Yes, okay. So now I will move to the second one now. I will not solve the third one because I already have done it for you. It's a revision. So the second one says list product description and its price. So how many attributes we are referring to? 2 attributes now, description and price. In the book, you will find something and in between. So this is the figure you can see here. It's from the book. But as I have highlighted before, you will be in trouble later on to identify how to join 2 entities together. Both of them are acceptable, but I will suggest you to use a comma in between. Okay, so you will find something like P description. Sorry, I cannot write properly because of this pen. I will try my best. And price. And the name of the entity. Okay. So here the issue is that in this case, we have only one entity. So we can accept it. But if we have 2 entities for the relational algebra, then it will make it wrong. So if you remember last time we have discussed or, and not. So if we have 2 entities, then we are trying to find the attributes from both of them. So if that entity is available even in entity 1 and entity 2 doesn't have it, still will be false. Okay, should I repeat it again? So whenever we are saying that why should we not use and, the book says and, you will find everywhere and, but I will suggest to you not to confuse, use comma in between. It is not incorrect, but I want you to use the same convention so you will not be confused later on. Here in one entity, it's acceptable. I have written that in your updated slide as well, so you will remember. But in case if we have 2 or 3 entities, then the result will be wrong. So which means I can write for you, maybe I can add one more slide here. Yeah. So for example, if we have 2 entities here, entity 1 and entity 2, let's say EID, E name. And we have something here, department ID, and we have department name. So if we are joining or selecting an attribute between both of them, the E name or department name, and we have used and in between. Right now, both of them are true. So in case, if our query says that we are also looking for location, but we do not have location in the department. So what will happen? It will still consider it to be a false, because one false means it is false. Okay. In that case, you will be in trouble to get a right answer. So it's better that you do not use an in between. So you will not be confused later on when we have 2 entities. and one of the entity doesn't have that attribute, will make other one false as well. So you can see here, e-name will be there, location is not there in the department. In that case, our query will become wrong and we will not get any output. Does it make sense, or should I repeat it again? Online people, should I repeat it again? One more time? Okay. So now we are saying that I'm giving you two scenarios here. The first scenario, we have EID, e-name, department ID, and department name. These are two entities I have. My first query says list. Let me try to write a little bit. E-name and department name. So we know that there are two different entities. Okay. E-name is from employee table and department name is from department table. So which means both of them are true. So result will give you e-name. So result here will be e-name and department name. Okay. In that case, we are fine. But when we have a question where we have to list e-name and location, and we do not have location here. I'm just saying that it can be here, but we do not have a location here in the department ID, which means e-name is true, whereas location is false. So if you remember the truth table, in truth table, if we have one false, it is equal to false, which means our result will be nothing, no results. Is it clear now? Is it clear? Does it make sense? Yes, please.
So if we used a comma, it would print e-names.
Yes,
Okay.
it will consider both of them. We have to only use whenever we have, for the attributes, I'm not suggesting to use it, but here you have a condition, then you can use it. Okay, you can find in the book that it says and, but it will confuse you later on when you are applying an SQL or when you are joining two tables together. Okay, is it clear now? Does it make sense? So what will be the right answer will be? So the right answer here will be, I'm writing on the top, pi, P description, and we have here price, and I have used a comma in between, and then parenthesis and the product name. Okay. So this will be our answer. This is for project. Any question before I move ahead? So you will find in the book, and I'm just clearly showing you because this figure I have taken from the book for you to understand. Do not confuse here. Okay. I don't want you to confuse. I'm telling you from now on what to use. So you will not be confused later on when you're using a joint. So now the next one is restrict. It says select, but this select means in relational algebra. We use a Greek letter, which is sigma. And we use a subset of rows when we use a restrict. In SQL, it is equal to what? Yes. So it is equal to where, which means whenever we have a condition, then we use restrict. Okay. So it is a condition. It is equal to condition. Let's look at one of the example. The first one, we have the same table of the product. So we have the same table as a product here. So first question says, find products that are available for less than $2. If you see the less than, greater than, and, or, these all are conditions. Okay. So which means you have to use an operator there. So we already have discussed and, or, not, all, any. These are all the keywords you have to look at in order to apply a condition as well. Okay. So these are some of the keywords. I will give you the list of the keywords you have to look at. So now I'll go back to the question, find the products that are available for less than $2. Do we have to select any attributes here? It didn't specify any of them. It doesn't say P code. It doesn't say P description. It doesn't say price, which means we are referring to all the attributes. In relational algebra, we do not select all the attributes only when we use a select, when we have to select only 1, 2, 3 attributes. Okay. So if we have all attributes, we do not use select. Okay. Because automatically it will apply on all the attributes. We just have to use a restrict here. So now let's use a restrict. Again, we are using a subset where exactly we have to apply the restrict on. Now the attribute we have to select because we have to apply the condition on the attribute. Which attribute we have to apply to? It says less than $2. If you look at the table, it is price. So we'll use a price which is equal to $2. Should we use quotations here? Should we use quotations? No quotations. Okay. How we know it? How we know it? Whenever we have integer, no quotations.
Oh, sweet.
Same for SQL. Okay, SQL accept it, but again, it's not a best practice.
Okay. So you only use quotation marks when you have characters.
Yes.
All right.
And for each database, I will remind you again that each database management system have their own syntax. Plus, each organization also has different convention to follow. I'm telling you the one which most of the organization follows, but might be when you start working, each organization might tell you to use a quotation. Some will tell you not to use a quotations.
Okay.
It's depend on database management system as well. I will also want to notify you. Last time we have used something called as upper and lower, right? It wasn't working in my SQL workbench. Why it wasn't working? Because we have to change the setting in order to filter it out. By default, my SQL workbench is considering all the letters. So upper and lower wasn't working for us. But for Oracle, it will work because each database management system settings need to be changed. By default, it accepted. So same software if you use in the Linux, it will not accept any conventions. It will not accept if you're using a combination of upper letter and the lower letter. Okay, is it clear? Any questions? And then I will move to you.
I was just at least it says to find the products for less than $2, but then you're finding the products equal to $2 with that.
Yes, it should be less than. Okay. I have used a wrong operator here. Thank you for letting me know. Should be. Is it correct?
Yeah.
Yes. Okay. So this is for the first one. The second one says P code. This is the one which will be equal to 311452. I'm not writing entire query. You can write the entire query as I have given to you in the last class. And you also have an answer in the next sheet. So before I move ahead with today's lecture, any questions here? So online students, do you have any questions before I move ahead with joins?
But I'm not sure if you haven't already answered it.
He's asking, like, if you're doing like a select all, it's logo, doing an RA, you don't do like pi, you can just do like sigma, whatever.
Or he asked you.
But will it work with pi anyway? Like, I don't know, I never tried that before.
Yeah.
I've never tried it.
Okay, who is asking that?
I don't know.
It's me.
Okay. But what's your question is because I cannot see your answer. Well, you don't need to
You said like you don't have to use pi, was it? If you're trying to
find
the
all the
full
list. But in SQL, you have to do that.
no, if you use it, would it be wrong? Because
How
for the
you can
last
use it?
exercise, because for the last exercise, I believe there was one question.
Okay.
You had-
I think so. Some of you might have used a ChatGPT and ChatGPT will give you answers something like this. I'm telling you, I know my students. I have been teaching this course for a long time. And from 2 semesters, I have been noticing that students are giving me something like this.
What? No.
Something like this.
Like, I think it's like you write down every attribute.
Yes, they gave me a different symbols because ChatGPT gives these symbols.
I just wrote all the attributes.
Okay, if you have given me all the attributes, it's still not incorrect. Okay. If you have given me all of the attributes, I will accept this time, but for the next time in your assessment, make sure you're not using it. Okay. Is it clear now? If you have all the products, all the attributes, you have to list down. You do not have to give me sigma, sorry, not sigma. Do not have to give me pi and all like asterisk or write all the attributes. Even if you're giving me all the attributes, it's correct, but you do not have to do that.
What should we?
You just have to use restrict and that.
Yeah, you just skip using pi and then.
Yes.
Okay.
Yeah. You have to skip using pi, just use a restrict, but in SQL, you have to use a select. Okay. Even if you're giving me, I will mark this time, but for the next time, you have to be careful because you do have a questions in your phase 1 of the project. Okay. Any questions, online students, before I move ahead? Do you get it? Jasmine, yeah, okay. Okay. Yes, I have said not to use it. You can later on go back to my videos. So you, in case if you do not understand me. Okay. For the sequence of operations, we said we can have one expression or we can have multiple expressions. What does it mean? We can write the answer in one line or one expression. One expression we have, or we can segment or fragment into 2 parts. You can do this restrict first and the selection first, or you can do the vice versa. Any of them will be acceptable because there is no rules you can find which says you have to follow the select first or restrict first. You will find all the researchers are giving you different concepts. Okay, so it's up to you how you want to do it. Just make sure that you are giving me arrow and giving a name, proper name. I do want to see temp there because intermediate expression means it's a temporary expression. So you need to give me a term called as a temp here. Okay, anyone else have a question here? Okay. So I will not go ahead with this one. Can we start with Cartesian product now? I have given a quick overview, so you do not feel like that I directly jump to a Cartesian product. Okay. So in Cartesian product, so you already have done a maths, right? Let's say we have A is equal to 1. Again, I have to, can I switch off my camera, please? It's better. Okay, so now you can see here, we have 2 sets here. One is called as A, another one is called as B, 2 and 4. So in maths, this is a question here. We have 2 sets are here. One is called as A, another one is called as a B. It consists of an element. So I'm calling these one as a sets. You have done that in union, intersect, and minus. Okay, so I'm calling these as a set. This is a set A, this is a set 2, which is set B, which consists of elements. These are the elements. 1, 2, 3 are the elements. Okay, so what we are doing here is that we are applying a product in between. So whenever we have a product in between, which means we use each element and combine with other one in the other set. Again, I will repeat again. So for example, if we have 1 here, we will make sure that it has an all combination from the second set. How it will be, again, I will repeat. The first element should be pair up with the second set, which is set B. So how it will look like? It will look like something 1 and 2 and 1 and 4. Then we will move to the second element and to the third element. So let's look at the second element, 2, 2, and 2, 4, 3, 3, 2, and 3, 4. Which means we are making sure that all the combinations are used in Cartesian product. Okay, this is what is Cartesian product. So I'm just giving you small example how the Cartesian product works. So you can see here we have number of attributes here. We have number of attributes are here. So here we have number of attributes, and each attribute consists of, okay, now it's showing me subtitles. So each attribute is showing me number of records. Each record should combine or create a pair with second records in the second entity. So it will look like something which I have solved here, but it is not correct. Why do you think it's not correct? Let's look at the output of this specific table. Why do you think it's not correct? Why do you think it's not correct? Because it is generating duplicates. Okay, so you can see here it is generating a duplicates here. Here in Cartesian product, we are combining two sets, which means two entities together. And for each record we have in each entity, we'll create a pair of each other, which means there are chances that the values which we have generated is duplicated. Maybe the values are incorrect or inconsistent as well. Okay, how we can avoid that? We can avoid that by something called as a join. We have number of joins are there. So what does a join does? Whenever we have two entities, 3 entities, 4 entities, from where we have to take an attribute from, we use a join. Again, I will repeat. So whenever we have one entity which need to be combined with the second one, we use a join in between. Or in other words, if we have attribute from 2 different entities, first step we have to do is that we have to join them. Else we will not be able to retrieve the information from 2 or 3 or 4 entities together. Okay. So what we have to do, how you know you have to apply the join? You will look at the attribute, which table it is belong to, then you know that we have to apply a join. Again, I will repeat, whenever you have a question, you have to look at an attributes, look at the tables, which attribute is belong to which table. If it is 2 tables from where you have to take those attributes, you have to apply a join. Does it make sense now? Understand or not? So let's say 2 entities, 3 entities, 4 entities, join need to be there. We have different type of joins, but we will focus on natural join, which is given here. For natural join, we use something called as an asterisk. Some of you call it as a star. Okay, so whatever you want to call it, you can, but it is asterisk, which uses a primary key and the foreign keys. We do have equijoin, which is for equality, theta join for the comparison. Outer join is for matching and non-matching, both of them. Okay, it's depend on whether we are using a full, one side can be left or right. I will explain the outer join more in detail next slide, next to next slide, yeah. Okay, so these are the ones which we are not using. We are only focusing on the natural joint in relational algebra. I do not want you to apply theta. I do not want you to apply the equijoin or outer join. Some of you will give me this symbol. It is from the ChatGPT, and I know you have used the ChatGPT. Okay, so make sure you're not using these ones because this one is something else. It is equijoin, which I don't want you to use it. So if I have said I want asterisk, I want to see the primary key, I want to see the foreign key, which means I want you to use the same syntax as I have mentioned, because I want you to learn how actually the joins work. Yes, please.
For a Cartesian product, like before, If you use the X, does it matter if it's small X or capital X?
It doesn't matter because we are not using Cartesian. Okay, it's for you to understand. We are not using Cartesian product. Okay. So one of your classmates had a question for the online students that can we use a small letter or capital X? Basically, we are not using Cartesian product. You will not have Cartesian product. Why I have explained to you because I want to understand the joint. Why we need to have a joint. Okay. So let's move to our first join. So this one is something for your understanding, but here also we are not going through these steps. This is for you how the joins work. Whenever we are using asterisk, which means it always use product, then it will select your attributes and then it will apply the constraint on it. Okay, condition on it. How exactly a join or natural join works, it automatically use a product. Then it's like the attribute you are interested into, and then it will filter out the records which we are interested into. This is how it works, but we are not following these steps. It's for you to understand that how actually the natural join go through number of processes or steps. Okay, is it clear? Can we see how actually the join works now? Can we see it now? Okay. This is how it looks like. Let's separate each of them, each of the statements separately. So what I will do here is that I want to separate this part. I want you to focus here because you will keep using the joins in SQL and the relational algebra. Okay. Specifically in SQL, you will be using it. So if you understand this well, you will be able to understand the SQL as well. Okay. So I'm separating each of them into 3 statements. This is my first statement. This is my second statement. And this is my third statement or expression. In the first one, I have selected. Okay. So in the first one, what I have done, I have selected all the attributes I'm interested into. So it doesn't mean that from all the entities or any of them, basically it depends on the question. So if question says customer code or customer zip, it should be only 2. If it says 3, you have to include the 3. How do we know in this first expression that we need to apply join here? So if you read the attributes, customer code, customer name, last name, zip, agent code, and agent phone. So you can see here agent and customer. So based on that also we can identify that we have taken these attributes from 2 different entities. Is it clear? Is it clear? Can I repeat again? I think I should do that. Okay. So it says customer last name, customer code, customer zip, agent code, and agent phone. Which means we are taking these all attributes. Some of them are from the customer table and some of them are from agent table. Which means in order to retrieve this information, we need to combine them together. We have to combine the entities together. We need to use a join here. Okay. Can I move to the next part? Is it clear? Yes, please.
People are asking you to full screen your chat.
Yeah. And to repeat. Well.
Full screen my chat. Okay. How it looks like? Can I see in your screen?
No, it looks like this. Yeah.
Okay, might be it's
You can use control.
no, it's fine. I have to check here. Maybe
First interview.
yes.
That's
Okay, so I don't know why it keeps showing me the same one. Because as per my end should show you both of them. Let me keep. Sorry.
That should be for, oh. No.
Yeah, good now.
It's good,
Yeah, right.
but now you will not be able to see it.
Right in one. Like first, like what we learn in. No,
Someone sent this corridor.
yeah, you write down.
Okay,
First, the statement. Yeah, and then the fraction.
okay, now is it okay? Or is it same? Online students, can you please check the ones who are on the
You have to join this together.
back? I think I have to do the full screen. For you guys, it will not be as a presentation. For them, it will be.
For viewers, there's an option to zoom in. It should be fine.
Yes.
For online people, they can just control and.
Because the issue is that the screen which I'm showing here will be small for the students who are here. The ones who are here, are you able to see this one?
Yeah.
Online students?
Yeah, they can do the whole thing now.
Yes, now they can see it, so it's fine. Can I move to the second part? I think the first one I have made clear what exactly you are doing it here. You see the attribute. It's from two different entities, which means we need to apply a join. Now let's move to the second one. We are applying the condition. You might have a question which doesn't need a condition, but in this specific question, we have to apply a condition here. So what is the condition here? Okay, I think so there is typo here. This should be a condition. Okay, so we can also consider this one. It is also correct, but condition should be different. So here what we are trying to do is that we are trying to restrict based on that agent code in customer table should be equal to agent code in the agent. Okay, so here in this condition, it's a little bit complicated, but it's supposed to be something different, but it's fine. This one is also acceptable. So here we have a restrict. In this restrict, what we are trying to do is that we are taking both of the tables. We have it here. So we are saying that we have two entities here, and both of them consist of agent code. So in that specific expression, what we are doing is that we are trying to find the agent code which is available in the second entity. So how we can do it? First, we have to write the name of the entity. Entity one. This is its foreign key equal to the second entity, its primary key. Okay. This is one way of doing it. So what we are doing is that because we want to make sure the primary key and the foreign key here is equal. So this is a condition here. Is it clear? I know it's a little bit complicated, but you have to identify which one have a foreign key and which one is a primary key. So for example, the customer have as a foreign key and the agent have it as a primary key. Yes, your question?
Is it supposed to be all lowercase?
Hmm?
For customer agent code, it's supposed to be lowercase,
It shouldn't be a lowercase because I have taken from the book.
so customer should be.
Yeah, it shouldn't be a lowercase because this is how it's given in the book. Okay, but use the capitals here.
Is that what the typo is?
Yeah, it's not a typo. The typo here is that should be a different condition, not this complicated one, because I want to show you something easier.
Oh, I see.
Okay, so now this one is very complicated for you to understand a join. But again, I want to explain to you, the condition is not wrong. It is not a typo, but I want to show you the simple restriction here. For example, how we have done the less or equal to.
So naturally when both tables that don't share like power,
Page 4.
that don't share.
They are sharing.
No,
It is not even not work.
Then a different one work.
You have to make sure you are selecting the correct table then. Okay? Complicated? Is it complicated? I know I want to change the restrict, but I forget to, I think so. Or might be I haven't updated. I wanted to change the restrict to make it easier. It is not wrong, it's not a typo. Only the thing is that I wanted to make it easier for you. But this one is also fine. We are trying to make sure the primary key and foreign keys are equal.
So when you write, Sigma, yeah, so when you write sigma and those two, right, so that's the same number.
Yes,
Okay.
it should match. But this restriction doesn't make any sense here.
Okay.
Is it? Okay, is it make sense? Because obviously when it is foreign key, obviously it will already be an entity tree. Okay?
It's just this expression is like.
So what I'm saying is the restrict here, it doesn't make sense. Why it doesn't make sense? I will answer to you. Why it doesn't make sense? Because primary key, obviously it will be there in the foreign key. Foreign key cannot be something else. It should be primary key in other table. Okay. This is an expression from your book and I have taken from there, but at least you need to understand it that it can also apply. That's why I want to change the restrict here, but I might have forgotten to change it. Okay, but understand this expression. It is not wrong, but it is not required. It is something can be considered, but it's not required.
What would be the other one that you want to show us?
I wanted to use equal to some numbers.
Oh,
Okay,
like the value itself?
the value itself.
So when customer.
Customer ID or something like that, or maybe equal to less than can you manage operating system.
I was just wondering, if you could maybe draw an example on the board.
Yes, I can draw the example for you. By the way, we have done the example for you already before, but I will do it once more time. Okay, let's say. Oh, huge number. So I can add one more slide here where I am now. So what we are saying here is that so what I'm saying here is that we can have customer code, we can have customer last name. I'm just giving, I'm not writing all the attributes here. I'm just giving a few of them. Okay. Because I don't want to write all of them. I just want to quickly give you the answer. So this was my first expression. The second expression here is my restrict. The restrict here, which I want to give you here is for the agent code. So the agent code can be equal to, or we can say that less than or equal to 113646, let's say. This is an example for the second expression. You close the parenthesis. You can add the other entities. Then we will apply a join here. I will explain the join in a while. Yes, your question.
In mathematics, A cross A is not the same as B cross A. So does that matter in this one? So like natural one? Like what it, the table of agent?
It matters. It matters. I will explain to you in two entities, it will not. But if we have three entities, we have to make sure the primary tree is there. So this is something we will solve in one of the questions we have. We have to take attributes from three entities, and we have to make sure the entity which we are joining with should have a primary key or foreign key which matches. Okay, I will explain that. I have one question for you, which is related to your question which you had mentioned. If you have two entities, doesn't matter. When it becomes 3, 4, then we have to make sure the order is correct. Okay. Any questions? Can I move ahead? So this is something which I wanted to show, and I'm showing you now. Can I move ahead with the third part, which is the join? Okay. So now for the third part, which is a join, make sure that you are, I will use different color for that, maybe blue. Okay, I don't like this color. So third one. So as we know that there are two tables are involved. Whenever we have two tables involved, the order doesn't matter. Okay. Order doesn't matter, whatever order you want to use. You want to use agent first, or you want to use customer first. The writing first, you have to mention it clearly. Okay. So what does it mean? I will explain to you. The name from where we are taking the specific primary key primary key. So table, name, and we have here what we all of them will be subscript. It will be equal to what? So then you will write the name of the second entity and the foreign key. Then you have to write here the name of the second entity. What the name of the second entity is? Customer. I will write for you here. So whenever you write something, the first thing you have to look at the entity, primary keys and foreign keys. In order to join them together, you need to have a so first entity you have to look at asterisk, whatever the entity we have mentioned here, the same name will be given here. It can be foreign key or primary key. In some cases, you will find a foreign key first and the primary key first. Okay, both are acceptable in two relation. But when it comes to three relation, we have to look at all the 3 or 4 entities. Based on that, we will be able to identify which one will come first. Okay, we will do that in exercise. Primary key, as per the question we have. Or maybe my computer is hanged. Okay, no more battery. So I can use a mouse for that. Or maybe I can type it out. Okay, so I will write for you the joint here, which will be much better. So we have entity 1 here. I cannot use in the PowerPoint. We have entity 1. Equal to entity 2, foreign key, and then the entity 2. How it will look like, I can write in the Word file for time being.
People Zoom don't see well.
They cannot see the word.
Yeah, it's typed on PowerPoint.
Also, your Wi-Fi is bad, like it's complaining that it's not moving down.
Yeah,
Like
it's actually freeze.
I get stuck on this part now.
Stuck on this part.
Yep.
Okay, so it will look like something like this.
Our Wi-Fi is going down, guys.
Okay, I will reconnect.
Literally watching you like 4 times.
Yes. I think so I already have clearly mentioned the join now, yes.
So the primary key is agent code.
Agent. Both of them exist in both.
Write it out.
Yes.
And then you give me another example, which is confusing.
But you like here, it's not a subscript, like it's a subscript.
It's a subscript. I'm subscripting.
Statements. Just looks like you're trying to join the private key and power.
Yes.
Is that what it's for? Is that what joins about? It's not joining.
Every entity,
Look at the wording.
same name should be here.
Yeah.
What about quotations?
Quotations, you can add the quotation as well, but when we are using a join, we do not add, not quotations, the parentheses.
Yeah, but what about quotations? Because these are.
No, we do not use quotations here. Yes.
If it was a word.
We will not use
Isn't it-
quotations, we will not include anything.
This is stuff that-
Parentheses only, we will add the parentheses when you're writing this expression. You can add the parentheses only here, but you cannot add something like this. Because it will confuse you a lot. If we have three entities, we will use multiple ones, and I will show you when to use, when not to use. Okay, so this one is incorrect. So this is how you have to write for two relation. This one, no. Okay, now the question, please.
So asterisks gonna be in subscript.
Subscript, yes. So asterisk here is subscript. So asterisk here is subscript. This is all subscript. Entity will not be subscript. Okay. Okay, for the online students, I will disconnect now and you can connect with me again. Maybe this will help us, but I don't know. Because from my end, all the signal is full. The strength is okay. But can you please confirm with me if you can see it? Hmm?
Word.
It works?
Words.
Okay, for me, I will save this one so you can have a look at it later on in case not write properly with this pen. So we have something.
People in Zoom is saying like don't disconnect.
Do not disconnect, right?
Saying don't disconnect.
Okay, it's fine. Okay, now let's look at the full outer join. So when we are saying the full outer join, this is for you to understand. Yes, please.
I have a question about the previous,
Yes,
method.
please.
So your latest example, your asterisk was subscript, whereas in the PowerPoint, it's the regular script, and I was wondering what the difference is. The PowerPoint. Oh, the PowerPoint's wrong. Okay.
Which one?
The PowerPoint with
Because it's taken from the book directly. So that's why it might have given me a typo.
okay, so
And it should be subscript.
that should be subscript.
Subscript, yes. You will find something online as well as a subscript. Let me see if I can show you now.
The same thing.
Join in relational algebra. Hopefully it will give me something better. But it should be subscript. You will get some of the symbols like these, but you do not have to use them.
So
It's fine. I'm just looking at something for you. Okay, you will not find it here. Maybe for the next class, I can bring for you.
Okay, yeah.
Okay. Yeah, because I need to look for it, and you can see here majority of the time you'll find some different type of equijoins. Okay. Theta, or this one is equijoin, which you will not using it. So you will be using something in SQL. So I want to stick to what you are doing in the SQL.
this equijoin.
Equijoin is for equality between both of them.
Okay.
Okay, which means both attributes should match.
So they need to be.
Yes. Yeah. Yes. Okay, let's go back.
Yeah.
Okay, so let's go back to the full outer join. In full outer join, we have something called as match and unmatch. Okay, I cannot use anything here. Okay, so you can see here we have something called as a full outer join, which consists of left outer join and the right outer join. So whenever we are saying the full outer join, it will look for matched tuples, which means it will look for only the columns which matches, which are common between both entities. So what is full outer join? When we are joining two tables together and we are saying that we are using full outer join, this is for you to understand, but we are not using it here. For you to understand that this is how it works. Because sometimes you have to use this one when you start working as a SQL developer. Okay, so you should know when to use it, when not to use it. Full outer join means whenever you have two entities and you want to make sure that you are joining based on common records in both of them. use fuller outer join. Then we have left and right. The left outer join is unmatched and the right one is also unmatched ones. Okay, so the left one, what will do, it will include the ones which doesn't match. The one which matches, it will exclude them. Only fill the left side and leave the other values which doesn't match as a null or pad it as a null. Same for the right one. It will match, it will look for the matching ones, exclude them, only take the ones which doesn't match, and then it will pad the one which is a null values. Example here. So you can see here the left join, the last row. We have Smithson. What will happen? We have joined two tables together. Okay, you can see here we have customer and we have agent as well. Okay, so you can see here we have customer and agent. So in customer, you can see here it has given us the values from the agent which doesn't match the last record. And the last one is empty. It's not empty, basically it is null. Why it is null? Because whenever we are applying the left join, it will only consider the one which is not matching. The rest of the attributes which is not exist, it will fill it with the null or pad with the null. Okay, we call it as a padding with the null values. Okay, so that's why we do not have any value here. If we have a matching which is full outer join, it should have a values here. Because I'm separating this part and this part as a two entities. Okay, is it clear? Same for the right, you can see here, we have information in the agent code, but we do not have in a customer. It is also unmatched, which means this information doesn't exist in the customer. This information about the agent doesn't exist in a customer table.
Does that mean if in right join, there was a customer code and we ran this expression of whatever it is, then it would fill out the customer name, customer zip, and customer agent code from the other table?
Okay, so what it is doing is that in the left one, left one, we have a customer and we have an agent code. But it is not, it doesn't exist in a agent itself. So whenever we are using a left and right, which means it doesn't match. The primary key and foreign key doesn't match. Okay? And the values which is not there should be padded with a null. It should be null here. Okay.
Like, if there's a record and agent code is by chance null in the customer's table, so will the record be in full outer join or?
If both of them are available, it means match, full outer join.
And if one of them is null, it won't be counted in the full outer.
Yes. Okay, you have to look at whether it's left or right. Okay, this is for you to understand because sometimes you have to use such kind of joins as well. Okay, because we are trying to retrieve an information which is not exist in, let's say, the agent. Okay, when it can be used, let me give you one scenario. In this scenario, we are looking for that agent which is not assigned to any customer or who doesn't have any customer. Then we can use what? We can use a right join. Again, I will repeat it where exactly we can use a right join. I'm giving you one scenario here. I'm looking for an agent. I'm trying to retrieve an information of the agent who doesn't have any customer. So what I'm doing is that I'm excluding the matching one and retrieving the information which doesn't match, which is the last one. So I have one agent called as code ID 333 who doesn't have any customer assigned. Okay, does it make sense when we can use it? I have given you one scenario.
So in the left join, the customer, whatever the last one, whoever that is, they didn't get an agent assigned to them?
Yeah.
Is that what it means?
Yes,
Okay.
and it is showing us a value, but it can be inconsistency in the database itself. Which means by mistake, they have mentioned the code, it has accepted here, but it doesn't exist. Okay, because sometimes whenever we are doing a filing, we can also do some typos. So here we can see that it is assigned, but we cannot see in the system that that agent exists. Yes, does it make sense now? Okay. Can we move to divide by now? We have spent a lot of time on relational algebra. Okay, so now let's move to the second one, which is divide by operator. When to use a divide by operators? You have to always look for keywords here. For example, every and all. So when do you have to use a divide by? So whenever you have a question which says every or all. My pen doesn't work still. I want it to be charged. Every and all. These are the keywords you have to look at, which means you have to use a divide by. Okay, write this down because it will help you to solve your questions which I have given to you. Okay, so now let's look at the question here. How we use it. We use a symbol divide, but I will suggest you to stick to the keyword or clause divide by something like this. You will find divide. You will find also like this as well. But I will suggest you to stick to one convention, which is divide by. Okay, stick to this one only. Because later on you will be confused. And I'm telling you, keep telling you these because you will be confused later on when you start working on SQL. Okay. So now let's look at one of the example. Find the suppliers who apply all the parts. So here we have two tables. One is suppliers, another one is parts. And now we are interested to find all the suppliers who have all the parts. How many parts we have? We have 3 parts. And now we want to look at which supplier have all the parts, because we are interested to buy from one supplier instead of from all the suppliers. Okay, so let's say we have a list of suppliers and we are looking for 3 parts. And for each of them have some of them doesn't have it. So what we are trying to do here is that we are trying to retrieve an information about a supplier who have all the parts, so we can buy all the parts from one supplier instead of multiples. Does it make sense, or should I repeat it again? Online students. Okay, I will repeat. So the question here says find the suppliers who supply all parts. Okay, here we have list of suppliers and we have 3 parts which we are looking for from the database. Okay, so we want to only select the supplier who have all the parts. So how we can do it? We'll look at each of the supplier and how many parts he have it. Maybe he do not have any parts. Maybe he have only 1 part, maybe 2 parts, maybe all of them. But we are not interested to know whether he have a 1 or 2 or none. We are interested to filter out only the 1 supplier or 2 supplier who have all the parts. Okay, because we want to order from 1 supplier rather than from multiple ones who do not have all the parts for you. So now let's look at here how we can do it. We are applying a division between both of the tables. The first step here is that whenever we apply a sort is that division, we sort the list. How do we sort them? Based on the primary keys. So you can see here, our primary keys are not in order. We have to make them in order. How we can do it? We will start from S01. So this one will move to the first one. Then we will look at the part 1, 2. Do S011 have part 2? Do he have it? No. He have as P013. I think it has also issues here. So I will change them here. Okay, so it is P03. So he have only 1 part here, which is P001, P003. So S01 have only 2 parts. If we look at S012, how many parts he does have? He have it?
3 parts, all of them.
All of them. So now let's look at S012, S012, and S012. This one is 001. 002, and 003. All three parts we have it. Now look at the third one. At 013. How many parts we have it? One. Only one. So what will be our answer should be? It should be S012, because we are saying that we are finding a supplier who have all the parts. So whenever we apply a divide by, this is how it will look like. Our answer should be S0112. Okay.
So.
So our answer should be something like this.
Just folder and so.
So you can see here we have two parts here, we have three parts here, and we have one part. So our answer should be at 012.
And then how we do it manually.
This one is manual, but this is how the operator works.
I know.
Okay.
What's the primary key in the first table?
The primary key in the first table is supplier number.
So
Mainly this table is considered as an associative table, but you do not have to worry about it now. Just focus on the concept itself and how it works. Okay, so here we are not talking about whether it's junction table, associative table, or it is a single table. Okay, we do have a relationship between them. We do have one more table here as a supplier. But here I just want to show you that how we can retrieve the information between two tables if you're using a divide by. Okay. Can we move ahead? Any questions?
How do you find it, like the syntax?
For that, divide by. I will show you. I have one example for you. I will solve for you. And I have mentioned earlier, whenever we have divide by, use which type of expression?
The expanded.
The intermediate expression, yeah. Expanded version, yes. Or temporary expressions. The different terminologies you will find for that. We will use intermediate one. So I will move to the set operators now. So this is something you have done before in your maths. We have union, intersect, and minus. We call these operators as a set operators. Anyone have a questions before I move ahead or give you 2 minutes to think about it or digest it?
When's break?
You want break?
Or when is it? I don't wait.
Or maybe we can solve this one and come back and solve the exercises. I can quickly go over these three operators because you know about them. We take a break. We will come back, solve the exercises, solve your exercise, we will move to the lab. Your today's lecture, which is ERD diagram, you will do the lab and I will explain in parallel the lecture. Okay? Because I have designed your lab in a way where we can have both of them together instead of one. So I will move here to the set operators. So this is something you have done earlier also in maths in your school. I have shown you, if you do not remember, I have to recall that whenever we're using union, intersect, and minus, we are saying that we have two sets here. Set 1, set 2, which consist of certain elements. Here, set means two entities. Okay, it can be two entities or two different type of conditions as well. Again, I will repeat here whenever we are using set operators, so you will not be confused later on. Set 1, A, so if you remember, I have said before, A can be 1, 2, 3, 4, 5. Set 2 can be 2, 4, and 5. It can be entity, or it can be expression from same entity. Okay, so I'm giving you both of them because maybe you will encounter something which has the same expression. So you will not be confused that why we have to use same expression. Okay, sometimes it can be both sets can be from the same entity, but different way of filtering out the information. Okay, so now let's look at the first one. Is it clear before I move ahead? What does that I mean by set 2, set 1, two entities and expressions can be same entity or can be from different entities as well. Is it clear, online students? Do you want me to repeat it? The ones who are in the class. Okay, you want me to repeat that? Okay, let's move ahead. So whenever we have a union, What does it mean? We use a symbol for that, something like U. What does it mean? We are adding them together, but what's the logic we use for that? Whenever we use a join, but why? What type of concept we use? We have two sets. When we are joining them together using union, what it will do? What will be the output should be?
One, to combine the tables.
Yes, it will combine the tables based on unique elements, unique records. So how it will be doing it? We have 1, 2, 3, 4 in first set, 2, 4, 5 in set 2. So whenever we are combining A, U, B, what it will do? Its result will be 1, 2, 3, 4, and 5. It will avoid the common ones. It will just take the elements which is unique. Here we are saying elements. In database, we use a record. So it will take all the unique records, remove the duplicate ones. Okay, remove the one which is duplicated. Is it clear? Okay. So you can write here it as a unique elements. Now the intersect, second online students, is it clear before I move ahead? Okay, so the second one you can also look at here, the diagram itself. It means we look at both of the sets. If you look at the intersect, we use a symbol M, but I will suggest you to use these keywords, union, minus, and intersect. Okay, use the keyword capital, all of them. So how we can do the intersect? We are using the same sets. So whenever we have an intersect, we are looking at the common. So you can see here in this diagram, we are looking at the common between each of them. What values are common here? We have 2, which is common between both of them, and 4 as well. So our output should be 2 and 4. Okay, so this one will be, intersect will be common. Is it clear? These are all basic math which you have done in your school. In case if you don't remember, it's a repetition of it. Okay. Can I move to the minus now? Make sure you're using a minus in the relational algebra. How it will look like. We call it as a difference as well. Okay, why I have used N here? Okay, so I will write it again. So A minus B. You also find something called as a difference somewhere, but I will suggest you to stick to the minus. Okay, please stick to the minus.
So A union B would be both of them. A intersect B would be the things that are similar
Common,
between both.
similar.
Then A minus B is just A without anything.
Okay, so what A minus B, what it will do? It will cancel the one which is common and take the unique value from one set, which is A. Whatever we have in the left side, we will consider the unique value from here. So what it does, we have a common values in between. So it will exclude the common values, take the one which is unique in our left corner side. If it says A minus B, this is A and this is B. It should take the common values of A. Okay, and vice versa. If it is B minus A, then obviously it should be B values. So let's look at here. What are the common values? We know the common values are these ones. And we are saying that A minus B, so we look at the set A, which is here. So what will the values which are left? 1 and 3. So answer here will be 1 and 3. Should I repeat? Should I repeat? Is it fine? Is it clear? This is how it will look like. We'll be using an SQL as well. So you should know how we use union, intersect, and minus. Okay, I will quickly show you the examples of them. Then you can go for the break and we'll come back and solve the exercises. Too much maths today?
Sure.
Yes.
So B minus A, it would be 5.
B minus
B minus A would just be fine.
Yes, it will be fine. Okay, so in case if you're using vice versa for B minus A. So here we are saying that B here is 2, 4, 5 minus 1, 2, 3, 4, 5. I'm writing it again for you. So we cancel the one which is common here. So what is left? 5. So answer here will be B minus A will be 5. Okay, is it clear? Can I move ahead, online students? Okay. So now let's look at the question 1. So how we can identify if we have to use a union, intersect, or minus? Here is a keyword. You have to always look at the keyword called as a or. So keyword here is or. And it should be 2 entities. Entity 1 and entity 2. Okay. So how we can do it? We will use the attributes which we want to make sure that it's common between both of them. We are interested in to look at the attribute first two attributes from here and from here. It says product ID, basically it is a product code. Okay. So what we are trying to do is our first expression here will be for the first entity, then second expression will be for the second entity. So now let's write first expression for entity 1. So what will be the expression will be? I want to select 2 attributes, which is P code and P description. And the entity name. So you can write here product list 1. I will use a union in between. I will write a second expression for this table. I want to match these attributes with these attributes in product 2. I want to match 2 lists together. I want to see that which one have a common attributes between them. Sorry, unique attributes between them. So we will use the same expression here because both of them having a same attributes and product list 2. Okay. Is it clear? Is it clear? The same expression. First, I have filtered out the attributes from here. This is my first expression. The second expression, I want to filter out these ones. Then I want to apply a union between them. What union will do? It will give me only the unique values from both of them, which means give me all the product, list of the products from both of the tables. And why we need to do that? Why we need to do that? Again, anyone can give me example for it?
The duplication of data.
No duplication of data. It's mainly a retrieval of the information. Okay, it is mainly for retrieval of the information. For example, here I have 3 sets of database systems. So I have 3 lists. So I want to filter out each of the ones so I can know how many number of students I have. So what I will do, I will use a union on it. I will take 3 lists. First expression will be for the first list, second expression for set B, third will be for set C. I use union, so it will give me only the ones who are unique. So I will be able to identify how many students I have, which is not repeated in any of the sets, in case if it happens. Okay. In second condition, I want to filter out the ones which are common between these sets. Maybe by mistake in the databases, we have duplicated the values. So in that case, I will use a union here. Same expression, but we are using a different intersect here. Okay. So you can see here it is only providing you with a common product code here for this specific example. What is the keyword here? It is and. So whenever you find and, which means you have to use intersect there. Okay. Then we have minus or difference. I want you to use the one keywords which is given you here. I will suggest you to use minus only. It says identify the product that appear in list but not in list 2. So the key word here is but not. I have highlighted for you the ones which you should look for. You have 2 lists, you have apply the minus, same expression, you just change the keyword here. Okay. So now any questions here? You can see here the minus 1 will give you all the unique values between product list 1 and 2. Yes.
In these three examples, why don't you project a price? Why don't you project the price?
It's up to you. I'm interested to only look for product code and description, not looking at a similar code or similar or unique price or something which is different from set B. I want to make sure these 2 column matches. You can also select one in case if you want to. Okay, I'm not interested to look at a common between the price also because it's all attributes. So it's depend on what is the question or what type of query you have to write in order to retrieve the information or what type of information you want to retrieve. Okay, is it clear? We can take a 5 minutes break and then we can start solving some of the exercises. Then we will start with our lab. Okay, is it clear?
From here.
Sorry?
Online students, do you have any questions?
Give me some part about.
Oh,
Okay, either way. It's easier to take it. So I actually want.
So you can join after 5 minutes.
Only 2 of those.
Yeah. It's product on top of each other.
P code,
I don't understand.
right?
Yeah.
The product name is P descriptor.